Hi everyone, thank you for listening the presentation, and I would like to talk about the two-dimensional laser scanning of historical railway station in Madinah. And my name is Professor Abdul Qadir Bhatti, and I am working as in the Department of Civil Engineering, and my specialty is also in structural engineering. So first of all, I will explain about the laser scanning. What is laser scanning? Normally, we are using the traditional way of doing the scanning by using the conventional survey equipments. So we shifted to point clouds by using the laser scanners. Uh, So in the laser scanning, we have very high density of the points or clouds. We call point clouds, which can be captured in a second, and it's a very fast way to capture the real-time drawing or real-time structures or real-time photos. So this is giving the laser light detection and ranging type of scanning, and this is normally we also call the lidars, or we also call it terrestrial laser scanning survey. So this is the laser scanner, and then we use the rays or laser points to detect the targets of the structures, and it will capture the whole drawings very quickly. So here we have the historical buildings, and then we have the laser scanners, and we use the laser scanner to capture the original drawings of the historical building. And now this is showing how the laser scanner work. So it's work in a three-dimensional way. It rotates in X, Y, and Z direction. So it will capture all the points in the 3D rotation. So basically, before we have very few resolutions, but after getting the advance in laser technology, we can capture more better or higher points. So here it's showing the conventional laser equipment like total station or other theodolite we use in civil engineering, and then it will take a lot of time to capture the points, like 1 point in 5 seconds, and it will be very difficult to do the survey within a very short time. So this is like a simple conventional measuring tape, and now we are advancing to the laser scanners. And this is here showing the how we get the laser points for the bridge. So we need maybe 100 or 50 points to actually measure the complete layout of the bridge. So this is a normal theodolite or total station we use to get the distances or location of the bridge, and finally we can draw the points on our drawings. But in case of laser scanner, we can capture very easily. So it's very good. It's data collection and control is very accurate. Safety is better, so we cannot stay more time on the roads and on the transport or some other structures where we cannot go easily. So we can use the laser scanners, and it will thoroughly capture the points, and we will not miss any targets which we need to do again. It's very superior than the traditional type of scanning, and then it will also reduce and the second trip, because maybe the traveling cost will be saved. And how this is work is also have the high visibility of the structures and capture realistic models, and it will also reduce our work. So it's we can use it in a information modeling, or it will give much better idea of the structures or ongoing activities of the project. So the laser scanning, first we have the concept phase, then we have design phase, and then development phase, and final we implement our laser scanning survey. So normally we process the data in the office, and we will capture the laser scanning for the whole area, and finally we will delete some points, and we just study the structure in which we need to follow or do some analysis. So these are the scanning processes. First step, we locate our laser scanner. In second step, we collect the data in the point clouds. And finally, we convert the 2D drawings and also in the 3D drawings models. So we perform laser scanning for the this museum building, and first it was used as a railway station in early of 19th century, and then it is nowadays it's converted to the museum, and this is uh, one of the best historical buildings in the Madinah. So here, these are the major equipments. We use laser scanners. We process the laser scanning data by using the software. Then we use some targets to capture the laser scanning points. And then we use the software to process our data and convert the drawings like AutoCAD or station drawings to print our data or to make a data from our laser scanning records. So first we perform the laser scanning, then we capture the data in our software and then register in the software, then extract models, and finally we use the 2D and 3D drawings from our data in different forms. So here we perform the laser scanning. This is the field scanning. In different locations we put our laser scanners. So we use 12 scanners, and then we collect the point clouds, and finally we create the 3D model, and finally we use the drawings, ground floor or elevations, and even we prepare the model for our structure analysis. So this is how we perform the laser scanning, and this is our target points. We can see the checkerboards here. So at least because this is a very large building, so we perform 12 different location laser scanning. Then later we register combined together. This is showing the scanning position of the laser scanning, and we use 12 locations to perform the laser scanning. And then we collect the data of each laser scanning and we compile it in the Farosine software. So this is showing the Farosine software. This is very user-friendly software, and we capture the records and we further this is a project created, then we import the data, then process it, then register, and finally we export our drawings into different forms. So here, this is how the project look like. So this will show scan different. This is showing the scan 2. There are 12 scans we recorded, and then we compile it into the import these scans in our software, and then we process it. For the all scans, 12 scans were processed here, and showing the final scan process for the whole area. Then we register the selected scan. So there are registration. I have two. One is automatic registration, another is the manual registration. So we perform both. So manual registration give us the better results. And then finally we select our different targets to connect each other. and later we did the registration, like these are the targets. So we use checkerboards to connect each target with neighboring targets. And finally, we can process the data, and it will give us the processed data in the Explorer form. And later we can export our data into different form. So we use the recap form, or we can also export in the AutoCAD file. So this is showing the recap model in which we can easily confirm our measurement of the historical building. And here there are different forms we can use, like AutoCAD, recap, or any type of different export options are available. So we can also export in the Revit, or in the BIM model we can also convert it. And finally, we can process the modeling and office processing, like here we have the point clouds. We convert the point cloud into the drawings, and there are various steps we perform at our computer simulation models in our lab. And finally, we can model and process the data. So we carry out the structural analysis of the whole building, and this is just only showing the one section of the arches and showing the stresses here, and we perform the static and dynamic analysis and confirm our data and the displacements. So finally, we apply the laser scanning technology to study the historical buildings and to check the stability and structural analysis. We found that the building is quite safe, and and also the laser scanning can be very easy process and give us a huge amount of data for various purposes. So thank you very much for your kind attention, and if you have any questions, you can ask me. Thank you.